Hi guys, welcome to Bit One Grade. In this video, I'm going to talk about how to make a price prediction on ticker from Binance Futures Exchange using machine learning model, specifically random forest model. Okay, so I'm going to use a machine learning model to make a prediction on price of tickers from Binance Futures Exchange. Okay. Okay. So I'm going to start with importing libraries, and I'm going to use a request library and pandas and numpy here. Okay. And for machine learning, I'm going to use scikit-learn. Okay. This is quite popular machine learning models, and I chose scikit-learn because they provide quite good documentation. And okay, so you need to install scikit-learn library to run this code. Okay, so I'm going to start with importing these libraries. Okay, and if you look at the libraries for scikit-learn, you're going to see that I'm going to import the greedy search CV. This is for cross validation. Okay, and I'm going to use the random forest regressor. Okay, so this is the name of the machine learning models that I'm going to use. Okay, and okay, and I'm going to set the symbol to be BTC USDT, and I'm going to make this code will make a prediction on close price of next candlestick. Okay, and the time interval will be 5. Okay, so I'm going to make a prediction on 5-minute interval candlestick. Okay, so that's what my code will do. Okay, and to start this code, I need to get the previous price data, and the in my other video I explained how to get the K line or candlestick price data from Binance Futures Exchange. Okay, so if you start with the URL and this URL. Okay, so if I read it, okay, so https://fapi.binance.com/fapi/b1/klines ? Symbol equals in a single quote, and I get the symbol from previous definition. Okay, so this will be BTC USDT, and interval would be 5 minutes. Okay, so here you get the 5-minute interval, and plus m, because this is a minute. Okay, so in a single quote, plus end limit equals 100. Okay, and this should be in single quote. Okay, so I'm going to use 100 most recent price data, and I'm going to train my machine learning model to make a prediction. Okay, and you also need to define data, which should be equal to request.get open parenthesis URL close parenthesis dot JSON open parenthesis and close parenthesis. So if you run this, you get the data from K-line data from Binance Futures in JSON format. Okay. And I'm going to define D to be data frame, the data we get from Binance Exchange in a data frame format. Okay. So, and I also I'm also going to define the put the labels for the columns for the data I get from Binance Futures Exchange, because it's easier to read. Okay, so I'm going to first run this part. Okay, so if you check what I have for D, as you can see, I have the the price data in a data frame format. Okay, so this is the raw material that we are going to use. Okay, so I'm going to define df to be D. Okay, and df will be the material that will be supplied to machine learning model. Okay, so machine learning will learn from this raw data, and then they make a best prediction. Okay, and if you for simplicity, I'm going to drop columns that include data other than numbers. Okay, so I'm going to exclude the close time, QAV, and its best match. Okay, so I'm going to get rid of those columns. Okay, so if you check what DF is, then everything will be here except close time, quantity of under asset value, and the east best match. Okay, so these columns will be removed. Okay, and we need to tell machine learning what the target is. Okay, so what which value the machine learning model will make prediction. So we have to tell them exactly what the target is to the machine learning model. Okay, unlike human, machines have to be told exactly, okay? And they do exactly what they're told. Okay? So I'm going to set the target to be close price. Okay, and I'm going to put dot shift open parenthesis -1 close parenthesis, because the prediction is for the next period. Okay, next candle. Okay, so I have to shift the row. Okay, let's run this. Okay, and there will be two. I need to divide the raw material into two parts. Okay, first is the train set, and the next part will be test set. Okay, so the machine learning will train will be trained based on train set. Then they will apply the parameters or things that the machine learning model learn to apply this to test set, and this set will make a prediction. Okay, because actually the machine learning model, the random forest model, can be quite complicated if we have to cover all the details. So this is for kind of entertainment. So I'm going to skip details and just get the main idea. Okay. Because if you obsess with the details too much, and you get exhausted, and nothing can be done. So for entertainment, for inspiration, I'm going to skip details for this video. But there should be a lot of videos on random forest. So if you are interested, you can take a look at the other videos, or get a textbook for machine learning models. Okay. So I'm going to divide. Okay. So X will be the training set and Y will be the test set. Okay. And I'm going to define U because this is used to separate the training and test set. Okay. Okay. And I'm going to put some loop, but this will repeat execute code only once. Okay. But I put it in loop because if you make an automated trading bot, then this process can be repeated if you put a number higher than 1. Okay. Or you can put it into while true loop. Okay, infinity loop. Okay. But for simplicity, I'm going to just 1 here. Okay, just okay. Okay, so I'm going to I have to define what training set is and what test set is. Okay, so training start to be 0, and training end is u. Okay, that we defined earlier, and test start is u, and the test end will be test start plus 1. Okay, okay, using this definition. Okay, so x underbar train, this will be x open square bracket train start colon train end, and a close square bracket. Okay, and I will do the same for y train, and x underbar set test will be equal to x open square bracket test start column test end close square bracket, and I do the same for the y underbar test. Okay, and this is the cross validation part. Okay, so okay. Okay. Actually, this is quite complicated, but the basic idea is I'm going to divide the training set into uh, okay, 10 pieces. Okay, okay, 10 pieces. Okay, then I'm going to ask the machine learning model to train. Okay, they make a do prediction on uh on 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 the training set. Okay, so they will do prediction 10 times. Okay, and check the error for the predictions from the training set, and this machine learning will compare the results from test set and what the real observation is. Okay, and the basic idea is that the machine learning model will decide the one that produce the least error in the training session. Okay, and that they apply the same condition to the test set and make the final prediction. Okay, so that's the idea. Okay, so I for this video just take this part as granted. Okay, so this part, this code will separate the test set and do the training for the machine learning model. Okay. Okay. Okay, and okay, this line, the parameters under RF, okay, will be will be hyperparameters that I'm going to assign the this program to test. Okay. And if you remember, we imported something called grid search, right? So when the when training session is conducted by the machine learning model, this model will test all combination of n estimators and the max depths, the hyperparameters, all kind of combination, okay, to find the optimal hyperparameter. Okay. And actually, there could be many hyperparameters can be added, but n estimators and the max depths are the main hyperparameters used by the expert. Okay, so but if you study more, you can add more hyperparameters to be tested. Okay, and in that case, you probably need more uh, computing power. Okay, but for this video, I made things lightweight, and I only use the n estimators and max depths. Okay, and I I I asked the machine to test estimators including 1, 500, and for max depths 1, 5, 10, and 15. Okay. 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 And the next line is the line for the grid search. Okay. The grid search underbar RF is equal to grid search CV open estimator equal to random forest regressor, okay, open random state equal to 0 close parentheses, and comma param underbar grid equal to parameters RF comma CV TSCV comma scoring neg underbar mean underbar squared underbar error. Okay, so this cross validation process will find the optimal uh, set of a parameter based on the score, which is the mean squared error. Okay, so this this code is trying to find set of parameter that would produce the least error, which is represented by mean squared error. Okay, and here the random state I put the random state because random forest model is based on process called bagging. Okay, so this process make a new set of data, okay, from the raw data set by randomizing every row of the data. Okay, then they make a new data set, then they do the training. Okay, so if you don't put a random state to be defined it, then the every time you do this, the result will be slightly different. Okay, but if you want to replicate uh, your prediction, then I recommend you to put random state option like my code. Okay. Okay, so this part will find the uh, best hyperparameter. Okay, and okay, and this part will train with the model. Okay, then we here this line will get the uh, parameter. Okay, the hyperparameter set. Okay, And as you can see from here, we can extract we get the what is the max step RF, the best max step RF. Okay, and another one is the N estimator RF. Okay, okay, then we get all the hyperparameter from a training set, and we finally apply this to make a final prediction. Okay, so RF is equal to random forest regressor open parenthesis uh okay so we this is a required parameter. Okay, and underbar estimator, and this comes from the here. Okay, the 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 best one we get from cross validation process. Okay, and the max step is the one that we get from cross validation process. Okay, and we define the random state to be equal to 0. Okay, for so that we get the same result after we if we repeat the same process. Okay, unless you define here a random state is every time you repeat it, the result will be slightly different. Okay, and then I'm gonna fit the model. Okay, the final fit. Okay, here, and you make a prediction based on the uh, previous test. Okay, so this comment RF dot predict open parenthesis x underbar test close parenthesis. This will produce the final price prediction. Okay, so let's run this code. Okay, okay, okay. Yeah, it might take some time. Okay, and the forecasted price for next 5-minute candle stick. Okay, candle would be 36,048.92 USDT. Okay, so this is the prediction that provided by the random forest machine learning model. Okay, so this code compared this is not a perfect model, but I think you can get the basic idea of how random forest model makes a prediction, and I use the data we can get from Binance Futures exchange. So I think you can if you do more research, I think you can customize it and make it a better model. Okay, so this is the end of this video, and I will come back with a more interesting and useful video. Thank you for watching.